Welcome to theastrodynamics.com and theastro.com. This website promotes the right way to build a commercial space catalog. I am Jim De. I develop computer codes for rapid and automated space catalog building. This website has many self-contained videos for catalog building. If you are familiar with any of the topics, you may skip to other videos of interest. This video presents the third of the three preliminary topics, optical and radar observations, commonly used as input to IoT and DC algorithms for rapid commercial space catalog building. Again, if power or HB4 is chosen for analytic perturbed orbit propagation in IoT and DC algorithms, then UCTs cannot be processed accurately. In turn, leads to only catalog maintenance. Since optical and radar observations of known and unknown objects are processed in ECI coordinates, and the input to the WinTy algorithm is the ECI state vector, same as two-body algorithms and numerical integration. The choice of the WinTy analytic perturbed orbit propagator leads to both rapid catalog maintenance and catalog building. The 2005 Space Control Center report indicated 100,000 and 300,000 observations per day were collected in year 2000 and 2005 respectively. Space debris generated from the 2007 Chinese ASAT, the 2009 collision of Iridium and Cosmos, the 2019 Indian ASAT, and many unreported space collisions probably increased the projected observations per day to 3 million or more in 2023. With this in mind, the Astro analytic perturbed algorithms are developed to process millions of observations per day for rapid catalog maintenance and catalog building. One optical observation contains two angle measurements, ray ascension alpha and declination beta. Remember that optical observations are normally collected at night. An orbit, which can be defined by a state vector, position and velocity vectors, contains 6 components. Therefore, to deduce an optical IoT state vector or an orbit, at least 3 sets of optical observations in alpha and beta or 6 angle measurements are needed. To develop IoT and DC algorithms, it is important to understand 1. Observations are not the same as measurements. 2. Observations cannot be propagated. 3. Angles only IoT or optical IoT starts with angles only, no range. First, US Air Force B3 input format of optical observations. The decades-old US Air Force B3 format has restricted accuracy to 4 digits beyond the decimal in degrees. However, in year 2023, many inexpensive commercial $100,000 or less electro-optical yield systems can provide accurate optical observations of 5 or more digits beyond the decimal in degrees. In many IoT and DC test cases, observations of 5-digit accuracy can produce more accurate IoT and DC state vectors. An important rule: the higher the observation accuracy, the shorter the observation arc or observation time span. That is, optical observations of 4-digit accuracy require longer time spans. In general, accurate optical IoT requires at least optical observations of 4-digit accuracy with reasonable time spans. Second, propose a free input format of optical observations. To improve optical IoT and DC accuracy, the proposed new free format of optical observations that takes advantage of 5 digits or more accuracy is recommended. The Astro has built over 10 optical ECI-based IoT algorithms to process optical observations with different observation accuracies, short or long arc or time spans, observations separated in seconds, minutes, and hours, from LEO to GEO, XGEO to cislunar and beyond. Note that an optical observation file contains satellite ID, sensor ID, time, ray ascension, and declination. Can you figure out the first observation of the US Air Force P3 input file? It is clear in the proposed free format file. One radar observation contains 3 measurements: range, azimuth, elevation, RAE, usually defined in topocentric coordinates of east, north, up, ENU system. Again, an orbit, which can be defined by a state vector, contains 6 components. Therefore, to deduce one radar IOD state vector, at least 2 radar observations in RAE or 6 radar measurements are needed. Range-only IOD is beyond the scope of this video. Transformation of ENU state vector to ECI state vector is straightforward, and the source code can be found in my book, Astrodynamics Algorithms for Rapid Space Catalog Building. Again, it is important to understand: 1. Observations are not the same as measurements. 2. Observations cannot be propagated. 3. Radar IOD starts with 2 angles and range. Radar observations are usually more accurate than optical observations, not to mention weatherproof, and therefore radar IOD and DC state vectors are usually more accurate than those of the optical. If accuracy is important and causes no problem, radar observations are usually more desirable. A radar observation file contains satellite ID, sensor ID, time, range, azimuth, and elevation, and or range rate. Range is usually at least an order of magnitude more accurate than the angles. That is, if range error of a radar observation is 10 meters, then azimuth and elevation errors are about 100 meters. The Astro has built an advanced multi-web Lambert IOD algorithms to process radar observations to produce state vectors of elliptic, parabolic, and hyperbolic orbits. Note that the proposed new free format takes advantage of observation accuracy with 5 or more digits beyond the decimal in kilometers or degrees. Accurate observations with field of view resolution of sub-arc second or greater than 5 digits beyond the decimal in degrees can be collected from 3 groups of optical and radar systems. Expensive system from the $110 million Optical Space Surveillance Telescope SST to the over $1 billion Space Fence Radar. 2. Less expensive systems of multi-million dollars Geode and Starlink. 3. Commercial optical systems of $100,000 or less in 2023. The Astro IOD and DC algorithms have been able to deduce consistently accurate state vectors from commercial optical systems using real-world observations from LEO to GEO, XGEO to cislunar and beyond. However, expensive and less expensive systems are still useful for other purposes. In general, given reasonable optical observation time span, observations with greater than 5 digits beyond the decimal in degrees, which is accurate enough for accurate IoT and DC algorithms. From observations to IoT and DC to catalog building. Optical observations are reasonably accurate and weather dependent, but much cheaper to collect than radar observations by a factor of 10 to 100 or more if costs of building, operation, and maintenance are included. Optical observations with unreasonable accuracy and or very short time spans may lead to less accurate and sometimes probabilistic track associations and multiple hypothesis theories, even without considering problems due to space weather, object maneuvers, among others. Rapid advances of inexpensive optical observations since about 2018 provide accurate optical observations and in turn reasonable IOD and DC state vectors. Radar observations are usually more accurate and therefore can be easier to produce accurate IOD and DC state vectors. Understanding of the three considerations leads to deterministic accurate IOD and DC algorithms, and in turn to rapid catalog maintenance and catalog building. To conclude this video, the third consideration, accurate observations, is highlighted as the red box in the top right corner. From experience gained from decades of hard work and access to real-world optical and radar observations, to the development of accurate analytic IOD and DC algorithms, have been difficult without the understanding of the three considerations. Insights and or luck rarely come without hard work. The Astro promotes new analytic perturbed algorithms for automatic commercial space catalog building. This website is not funded or supported by or related to any government. The opinions expressed in this website are purely based on decades of research. Again, this website promotes an alternative method for efficient automatic commercial space catalog building. This video presents the third consideration, optical and radar observations for commercial space catalog building. Today, many commercial space companies are building their commercial SP and TLE space catalogs. If the SP-WINTI method is used, they can take advantage of the accurate state vectors in their SP commercial space catalog for analytic perturbed object propagation for robust automatic catalog maintenance and catalog building. Understanding of the three considerations is important to the development of accurate analytic IOD and DC algorithms, and in turn, rapid space catalog maintenance and catalog building, and space domain awareness, SDA. Next topic, track association or correlate observations, IOD and DC algorithms. I am Jim De. Thank you for watching this video of theastro.com.